Next topic is specific heat capacity, which means the substance will be increasing in temperature by heating. What are the changes occurs in the volume and pressure? Okay. So first thing is we will see that specific heat capacity at constant pressure. Okay. So this is a cylinder. Okay, it's a gas. It's taken the container. This is a ideal gas. Okay. This is a piston is attached here. This is a movable piston. While heating, what will happen? The temperature of the gas will be increased so that its volume will be expansion. So volume will be increased. If the volume will increase means what will happen? Pressure is constant. So this is the condition. So at the constant pressure of gas, the volume will increase while temperature is given to the cylinder. Okay, this is called what? Specific heat capacity at a constant pressure. Okay, in this case, the process of the part of the heat energy, okay, it is used to doing work, which means expanding that volume. Okay, and the remaining part of work is increasing the internal energy of the gas. Okay, clear? The part of energy is required to doing the work, that's called expansion in the gases. Okay, the remaining part of the heat is used for that increasing the internal energy of the gas at a constant pressure. In case of constant volume, see, this is a cylinder. It is pinned with that cylinder, the piston. So it means it's not movable. Okay, so the volume is fixed here. So at a constant volume, okay, of gas, if given it is given, what will happen? Its pressure is increased. Okay, so here you have to find out the what is the specific capacity of the gas at a constant volume. Clear? So constant volume means the pin is that it is attached with that cylinder, so it won't to move up and down. Okay, so this is the meaning of constant volume condition. Okay, here there is no work done because the cylinder piston remains same here. There is no work done, so only the heat is given, it is used for that internal energy increase in the gas, that's all. Okay, now we will see the definition of these two. Okay, specific heat capacity at constant pressure and at constant volume. Okay, at constant pressure means put P is constant here, and the constant volume is V is constant, the circulating gets constant. Okay, so here the amount of heat energy Q is required. The amount of heat energy, symbol is Q, is required to raise the temperature of 1 degree Celsius or 1 Kelvin, okay, of the substance of 1 kilogram. That is the meaning of specific heat capacity. So symbol is SP. Okay, here the constant volume, the amount of energy is required to raise the temperature of 1 degree Celsius or 1 Kelvin of 1 kg of substance. This is called SV. Okay, so both are same in definition, but that constant pressure here at constant volume here. So using this thing, okay, SV is always greater than SV. Okay, according to increase the temperature of the gas, okay, at constant volume requires the less heat than increasing the temperature of the gas at a constant pressure. Okay, now so that we write as SP is greater than SV. So using this concept, we can find out that molar specific heat also. Molar specific heat capacities, that is Cp and Cv. Same thing, at a constant pressure, the amount of heat energy Q is required to raise the temperature of the substance of 1 degree Celsius or 1 Kelvin by the 1 mole of the gas substance. 1 mole of the gas substance. The constant pressure means this is the meaning of Cp, molar specific heat capacities. If at the constant volume means same thing, we write as Cv. Okay, here the 1 kg meaning specific heat capacity. Here 1 mole means is the molar specific capacity, the only difference. Okay. Now we will find out what is the formula for the CV, that is the molar specific capacity at a constant volume. Okay. If the Q is amount of heat supplied to the mole of the gas at constant volume, okay, temperature is changes by the amount of del T. So T is changes of del T, which is changing its temperature. So the amount of heat energy Q is equal to number of moles is C at constant volume of mole of so the heat capacity. The temperature is changes in del T. So this is formula for the amount of heat energy Q. Okay, put that equation number 1. You know that first law of thermodynamics. According to the first law of the thermodynamics, at a constant volume there is no work done. Okay, so you put if W is equal to 0, the first law of the thermodynamics become Q is equal to del U minus W. W equal to 0 means it will become Q is equal to del U only. Put the equation number 2. Because of at a constant volume concept, there is no work done by the gas. Okay. So compare equation 1 and 2. We have Q in the left side, so equal in the right side. Okay. So we'll get del U is equal to mu CV into del T. Okay. So in this relation, what is CV? So multiple of things can divide here. So let us mu is 1 by mu. Then we have del U in the left side. Multiple of del T divide here. So CV is equal to 1 by mu del U by del T. Okay. Certain time there is no change in the temperatures. Okay, which means the Tf minus Ta equal to 0. Which means the same temperature. Okay, so del T tends to 0. Okay, there's a limit. Okay, we'll write as CV is equal to 1 by mu. Then the del means between the 2 points, it become at an instant. So we'll write as du by dt. Du by dt is called what? A change in temperature in internal energy. The change in temperature. Okay, clear? So this is the formula for what? Molar specific heat at constant volume. Okay, since the temperature and internal energy are state variables, okay, the mu is called mole of the substance of the gas remains constant.